Question number 6. Find the derivative if y equals to x to the x into sine x to the 2x into x to the 9 plus x to the second x. Again, look at here. It is a function-to-function expression, but there is a product of three function-to-function expressions: x to the x, sine x to the 2x, and x to the 9 plus x to the second x. So there is a product of two function-to-function or variable-to-variable terms. So I'm going to apply the logarithmic product rule here. But before to apply the logarithmic product rule, I must have log here. As usual, we do for the function-to-function. Let me take log on both sides to have natural log of y equals to natural log of x to the x into sine x to the 2x into x to the 9 plus x to the whole second x. Now we can apply the product rule. By applying the product rule, I will have natural log of x to the x plus, because there is a product here, natural log of sine x to the 2x plus, because there is a product here, natural log of x to the x plus x to the whole second x. Just apply the product rule. And then apply the another basic rule, which is this one, natural log of a to the b equals to b into natural log of e, which equals to natural log of y equals to x into natural log of x plus 2x into natural log of sine x plus second x into natural log of x to the 9 plus x. Look, apply this rule for all the three terms one by one. So let me first pick the first term, which is natural log of x to the x. My x is b here, and my this x is a. So just apply that rule. It equals to x into natural log of x. Similarly here, when you pick the second term, my b is 2x, and my a is natural log of sine x. And then pick the second term, my b is 2x, and my a is sine x. The sine x is my a. So I'm going to put 2x in front of the natural log. It will be 2x into natural log of sine x. Similarly, the third term, my b is second x, and my a is x to the 9 plus x. So bring this second x in front of the natural log, which is second x into natural log of x to the 9 plus x. Now take derivative on both sides. As I said, before to take the derivative, I applied the product rule here, which was natural log of a into b equals to natural log of a plus natural log of b. I applied that product rule here because there is a product of this term and product of this term with the third one. So it equals to plus, it is like natural log of a plus natural log of b plus natural log of c. Now when it comes to derivative for the left side, I apply the implicit differentiation. Natural log of y is 1 over y into dy over dx. And then for the other three terms, I applied the product rule, the derivative product rule. So let me apply the product rule one by one for all the three terms. For the first term, it is a product of two functions, x and natural log x. This y is one function and this x is another function, so it's a product of two functions, x and natural log x. According to the product rule, put x as it is and take the derivative of natural log, which is 1 over x, and then times the derivative of the inner function, which is x. So derivative of x is 1, plus then take the derivative of x and put natural log of x as it is. Now pick the second term. Here is also the product of two functions, 2x and natural log of sine x. This natural log of sine x is one function, 2x is another function. There is a product between them, so I'm going to apply the product rule. According to the product rule, put 2x as it is and take the derivative of natural log of sine x, which is 1 over sine x, and then take the derivative of sine x. So derivative of sine x is cos x. Even when you take the derivative of the innermost function, which is x, so derivative of x is 1. So whether you put times 1 or not, it is up to you. But if there is sine x squared, so you will have cos x squared, and then you have to take the derivative of the x squared, which will be 2x. But since it is x, so its derivative is 1, therefore I don't need to put times 1 here. But since it is only x, so derivative of x is 1, so therefore I don't need to put times 1 here. Plus, and then on the other side, take the derivative of the first function, which is 2x. So derivative of 2x is 2, and then put the other function as it is. Put natural log of sine x as it is, plus, and then comes to the third term, which is second x into natural log of x to the 9 plus x. Again, it is the product of two functions, second x and natural log of x to the x plus x. So apply the product rule here. Derivative of secant x is secant x times tangent x, and then put the other term as it is, which is natural log of x to the 9 plus x, plus then take the derivative of the second function. So derivative of natural log of x to the 9 plus x is 1 over x to the 9 plus x times the derivative of the inner function. So derivative of the inner function is this, x to the 9 plus x. Derivative of x to the 9 is 9 into x to the 8, and derivative of x is 1, and then put secant x as it is. So I applied the product rule, the derivative product rule for all the three terms. Do simplification to get this expression. I want to take dy of dx out, so this y comes on the right side. It is here. It will be the product of this whole expression here. This y cancels with the y, so 1 times 1 is 1. I will left only with a 1 here, and natural log of x times 1 is natural log x, and then 2x times cos x will be 2x cos x or sin x, plus 2 into natural log of sin x will be 2 times natural log of sin x, plus secant x into tangent x into natural log of x to the 9 plus x here, and then plus there's a product here in the numerator, so it will be secant x into 9 times x to the 8 plus 1, or x to the 9 plus x into y. This y comes from here, from the denominator here. Now put the value for the y. The value of y is this expression. It equals to x to the x into sine x to the 2x into x to the 9 plus x to the whole secant x. Just put this expression for the y because it equals to y here. Put it here for the y. So my final derivative expression will be this. I just plugged y equals to this expression. This is going to be my final derivative answer for the given function to function expression. But don't forget, it is not the simplified version. You can do more simplification here. It is not the end. Do some algebra and stuff. It is up to you. But for timing, this is derivative of the given expression.